Good day, students. Today we are going to see the quick recall session of carbon and its compounds. We have various topics: bonding in carbon, versatile nature of carbon. Under that, we are going to see saturated and unsaturated carbon, chain, branch, and ring structure, functional groups, homologous series, and nomenclature of carbon compounds. Then chemical properties, which is combustion, oxidation, addition reaction, and substitution reaction. Some properties of ethanol and ethanoic acid. Finally, we are going to see soap and detergents. Under this, the structure of micelles will be seen. Coming to the next topic, bonding in carbon, the covalent bond. Why carbon has a covalent bond? To attain the stability, carbon share electron with other elements. So the bond which is created by sharing electron with other element is termed as the covalent bond. Here we can see 20 elements. Totally we have 118 elements in the periodic table, but we have listed only 20 here. The outermost shell of all the atoms is termed as a valency shell, which determines the chemical properties of an atom. The valency shell should have 8 electrons to attain noble gas, which is also called as inert gases, which has low reactivity. It attains stable, so it will not combine with any other element. We can see carbon atom here with a mass number 12 and atomic number 6. A mass number is represented as A and atomic number is represented as Z. We can see the dotted structure also here with K shell 2 electrons and L shell with 4 electrons. Why carbon neither gain nor lose electron? Because the valency shell of carbon has 4 electrons. To attain stable, this carbon has to either gain 4 electron or lose electron. To gain more electron, the carbon has to be more stronger, but 6 proton cannot hold 8 electron. To lose 4 electron, it needs more energy, which is also not possible. So it is neither gaining or losing electrons. Coming to the next topic, ionic bond. Ionic bond means giving or taking of electron. So it has high melting point and boiling point, and it is a good conductor of electricity in solution. So carbon compound has covalent bond, so it has low melting point and boiling point. The force of attraction between the molecule will be less, and it is very poor in conducting electricity. So covalent bond means we know already it is a sharing of electron between the two elements to attain stability. The bond which is created is called covalent bond. Now here you can see the example of hydrogen. Hydrogen has atomic number 1, which attains stability by sharing electron with another hydrogen atom to form H2. Now we can see the structure here with sharing electrons by forming a covalent bond. So example for noble gas is helium. Helium has an atomic number 2, which is a noble gas in the periodic table. Now we can see the examples for single covalent bond, double covalent bond, and triple covalent bond here, with the structure how they share electrons through covalent bond. We can see the examples here. For single covalent bond has hydrogen, methane, ethane, and hydrochloric acid, and for double covalent bond is oxygen, carbon dioxide, and ethane. Coming to triple covalent bond, we can see the example as nitrogen and ethane, butane, propane. Here we can see water molecule, which is the combination of hydrogen and oxygen. Two hydrogen atom combined with oxygen through single bond, whereas nitrogen is an example of triple bond. Followed by, now we can see the examples of single bond. Here various example has been given through structure for the better understanding. Now we can see here CH4, which is called as methane. It plays a major role in a fuel, biogas, and CNB. The full form of CNB is compressed natural gas. Now coming to double bond, these are the examples of double bond as we have seen already: oxygen, ethane, carbon dioxide, and carbon disulfide. We can see double bond here. Then coming to triple bond, nitrogen, ethane, propane, butane is the example of triple bond. Coming to the next topic, it is tetravalent. Carbon is a tetravalent. We can see the chemical formula of methane is CH4. To attain noble gas configuration, 4 carbon atoms will combine with the 4 atoms of hydrogen. So next we are going to see the difference between the ionic bond and covalent bond. The first point is ionic bond has high melting point and boiling point, whereas covalent bond has less melting point and boiling point. Transfer of electron takes place in ionic bond, whereas sharing of electron takes place in covalent bond. High intermolecular force of attraction takes place in ionic bond, whereas less intermolecular force of attraction takes place in covalent bond. Electrons are not shared in ionic bond, whereas strong bond formed between the molecule due to covalent bond. Charged particles are seen in ionic bond, whereas no charged particles are seen in the covalent bond. Ionic bond is a good conductor of electricity, whereas covalent bond is poor conductor of electricity. Carbon compounds have low melting point and boiling point. The reason is carbon compounds form covalent bond where there is a less intermolecular force of attraction between the molecules. This leads to the low melting point and boiling point. The next topic we are going to see is allotropes of carbon. Allotropes means same element with a different structural form which has different physical properties with same chemical properties. Now we can see the examples here: graphite, diamond and Buckminster's fullerene. Graphite is a good conductor of electricity. It acts as a lubricant and it is slippery. Whereas diamond is a poor conductor of electricity which is hard in nature. Buckminster's fullerene, which has a geodomain shape. Coming to graphite, we can see the carbon atom here. 3 carbon electrons are bonded with the other carbon atom, whereas 1 electron is left free. This free electron leads to the good conductor of electricity and it is a layered structure, slippery in nature, which act as a lubricants. Coming to diamond, all the 4 electrons are bonded with the carbon atom, no free electrons, so it is a poor conductor of electricity. Next, coming to fullerene, it is a shape of football, look like a geodome, designed by the US architect Buckminster Fuller. So the molecule is named as fullerene with the carbon 60. Coming to the next topic, versatile nature of carbon. Versatile means adaptability. Carbon is versatile in nature. Why it is named as versatile? It has a property of catenation. Catenation means carbon get bonded with other carbon atom. The bond between the carbon atom can be seen in a chain form or branched form or in a ring structure. So single bond is named as a saturated compounds, whereas double or triple bond is named as a unsaturated compounds. Compared to silicon, carbon has a strong bond because it is stable and it can form a large number of compounds, whereas silicon can form only 7 or 8 atoms together. Coming to the next topic is tetravalency. Why carbon is named as a tetravalency? Because the valency shell has only 4 electrons. So 4 means tetra, so it is named as a tetravalency. Carbon will form compound with oxygen, hydrogen, nitrogen and chlorine. The organic compound has 2 characteristic features, that is tetravalency and catenation, as I told you already, which leads to the large number of compounds. Coming to the next topic, saturated and unsaturated carbon compounds. Here, saturated means single bond and unsaturated means double bond and triple bond, as we have seen already. The single bond elements are named as alkane, whereas double bond and triple bond is named as alkene and alkynes. So the example of alkane is methane, ethane, butane, propane, etc. Whereas coming to alkene and alkyne, the example of alkene is ethene and example of alkyne is ethine, butane, etc. Now let us see the structures. The structure can be in chain, branched or in a ring form. Structural isomers. It is nothing but the element which has the same chemical formula but with different structures. Now we can take an example, butane here. Now let us see about the hydrocarbons. All the compounds which has carbon and hydrogen are termed as hydrocarbons. It is seen in both the cases as saturated hydrocarbon as well as in unsaturated hydrocarbons. Let us take an example, butane, which has 4 carbon. It has 2 possibilities, one is chain form, another one is branched form. Now, satisfying the valencies, we are getting 2 different structure, but the chemical formula is same. So this is termed as structural isomers. Now we can see the example for cyclic structure, that is cyclohexane. This is the electron dot structure of cyclohexane. So it can be either saturated or unsaturated hydrocarbons. Coming to the functional group of carbon compounds, we are going to see the compounds with the functional groups. First one is halogen, where we can add chloro or bromo in the prefix of the compound. The next one is alcohol, aldehyde, ketones and carboxylic acid can be added as a suffix. alcohol with OH, aldehyde with CHO, ketone with C double bond O, carboxylic acid with COOH. The next topic will be the homologous series. Here we can see the carbon is linked to form a lengthy chain which can be also branched one. Here in this, hydrogen is replaced by the functional group which decides the properties of the compound. For example, methanol, ethanol, propanol and butanol, which has a same property because it has a same functional group OH. So this is called as a homologous series which differ by the CH2 group. Next, coming to the nomenclature of a carbon compound. Naming of the compound in homologous series is based on the basic carbon chains present in it, and it also indicates the nature of the functional group. For example, we can see the naming of carbon compounds here. According to the number of carbon compound, it is named as propane. Then according to the functional group, it can be named as follows. Halogen groups are named as chloropropane or bromopropane, alcohol as propanol, aldehyde as propanal, ketone as propanone, carboxylic acid as proponic acid, alkenes as propene, alkynes as propyne. Coming to the chemical properties of carbon compounds, we have combustion, oxidation, addition reaction and substitution reaction. Combustion is nothing but the oxidation. During this process, we can see heat and light getting evolved. Saturated hydrocarbon gives clean blue flame, whereas unsaturated hydrocarbon gives yellow flame with a lot of black smoke. This is the reason for the blackened surface under the vessels which we cook at home. Now coming to the fuels, coal and petroleum, which has amount of nitrogen and sulfur during combustion, leads to the formation of oxides of sulfur and nitrogen. This is the major pollutant in environment. Next, coming to oxidation, carbon is getting oxidized, which is called combustion. In addition, alcohol during oxidation leads to carboxylic acid. We can see the example here. Methane with alcohol gives rise to the acetic acid in the presence of alkane potassium permanganate or acidified potassium dichromate. The next one is addition reaction. During addition reaction, unsaturated hydrocarbon leads to the saturated hydrocarbon in the presence of catalyst, which can be palladium or nickel. This catalyst cause the reactions to occur at different rate without affecting the reactions. During hydrogenation of vegetable oil, the catalyst which is used is nickel. Vegetable oil leads to the animal fat during this addition reaction, which is from unsaturated carbon chain to saturated carbon chain. Vegetable oil is good for health, which is healthy, whereas animal fat is saturated fatty acid, which is harmful to our health. Coming to the substitution reaction, it is nothing but the replacement of hydrogen atom in the hydrocarbons by chlorine. We can see the reaction here. Methane plus chlorine gives rise to chloromethyl plus hydrochloric acid in the presence of sunlight. This is called as a substitution reaction. The next topic is some important carbon compounds. In this, we are going to see ethanol and ethanoic acid. First, properties of ethanol, which has melting point 156 Kelvin and boiling point 351 Kelvin, which gives liquid state at room temperature. It is an active ingredient in the preparation of alcohol, whereas a good solvent which is used in the medicine in the preparation of tincture, cough syrup and many tonics. It is soluble in water in all the proportions. Small quantity of intake leads to lethal, whereas long term gives us health problems. Coming to the reactions of ethanol, ethanol reacts with sodium to give sodium ethoxide plus hydrogen. To give unsaturated hydrocarbon, ethanol reacts with excess of sulfuric acid at 443 Kelvin to give ethane with double bond plus water. Coming to the properties of ethanoic acid, which is also called acetic acid, it is a group of carboxylic acid. 5.8% of acetic acid plus water gives us vinegar, which can be used as a preservative in pickles. Melting point is 290 Kelvin, which leads to freezing state in winter season, which is also called glacial acetic acid. Coming to the reactions of ethanoic acid, we can see esterification and the reaction with the base and with carbonates and hydrogen carbonates. Esterification is nothing but acid plus alcohol gives rise to ester, which is called esterification, which has a sweet smell used in perfumes and flavoring agents. In this, we are going to see one more reaction, that is saponification. It is nothing but ester in turn reacts with sodium hydroxide to give alcohol and sodium salt. This is called saponification. It is nothing but the preparation of soap. Now coming to the reaction with base and with carbonates and hydrogen carbonates. ethanoic acid react with sodium hydroxide to give sodium ethanoate or sodium acetate, which is called as salt. Coming to the final topic, soap and detergents. The effect of soap is cleaning. The molecules of soap seen here are sodium or potassium of long chain carboxylic acid. We can see the structure here, which has head part as well as tail part. The head part has a sodium ion which has ionic end, whereas the other side has tail part with a carbon chain. Ionic end react with water and it gets attracted towards the water, whereas carbon chain reacts with oil or the dirt and it gets attracted towards the oil. So now we will get a shape which is called missile. In some cases while bathing, there will be a difficulty in the formation of foam due to the insoluble substances called scum, which remains even after washing with water. So soap with calcium and magnesium leads to the hardness of water. In this case, we need large quantities of soap. To overcome this, we are using detergents. Detergents is nothing but the sodium salt of sulfonic or ammonium salts with chloride and bromide ions. The charged end of these compounds do not form any precipitate with calcium or magnesium ions in the hot water. So it is used in the preparation of shampoos and other products of cleaning clothes. Yes children, with this we have come to the end of the session. These notes are available as a PDF. Please go to the description and get the PDF for the reference. Thank you children.